Have you ever wondered what secrets the universe holds beyond the reach of our backyard telescopes? Well, let's take a cosmic journey together to explore some of the universe's most intriguing curiosities. Imagine a superstructure so vast, so grand, that it's hard for our human minds to truly comprehend. That's exactly what we're dealing with when we talk about cosmic superstructures. These colossal formations of galaxies and galaxy clusters are the largest known structures in the universe. One such superstructure, affectionately named the Big Ring, stretches across an unimaginable diameter of 1.3 billion light-years. And if that's not enough to make your head spin, there's another superstructure, the Giant Arc, that's even larger with a diameter of 3.3 billion light-years. Surprisingly, these two behemoths lie in close proximity to each other, nestled in the constellation of Bootes, the herdsman. These superstructures are not just vast, they are mind-bogglingly complex. They challenge our understanding of the cosmos and leave us with more questions than answers. But isn't that the beauty of the universe? It's an endless source of wonder, waiting for us to unravel its mysteries. The discovery of these celestial giants was not a result of their brightness, but their shadows. Let's delve into the discovery process, shall we? Alexia Lopez, a PhD student at the University of Central Lancashire in the UK, was observing the cosmos using the 2.5-meter telescope of the Sloan Digital Sky Survey at Apache Point in New Mexico. U.S. Lopez spotted the galaxies in these superstructures, not because they were shining brightly, but rather due to their propensity to absorb some of the light emanating from distant quasars. Now, quasars are fascinating phenomenons in themselves. They are the extremely luminous interiors of active galaxies, powered by supermassive black holes. The galaxies in the Big Ring and the Giant Arc, therefore, stood out as shadows against the backdrop of these vibrant quasars. This absorption of light was the key that unlocked the existence of these galactic giants. An observational triumph, to say the least. But what's most intriguing is the close proximity of these two ultra-large structures. It raises the possibility that they might form an even more extraordinary cosmological system. The discovery of these superstructures raises intriguing questions about the nature of our universe. The Big Ring and the Giant Arc pose a fascinating conundrum to cosmologists. They challenge our understanding of the universe, questioning conventional cosmological theories. To understand why, let's delve into the cosmic microwave background, or CMB, and baryonic acoustic oscillations, BOs. CMB is like the universe's baby photo, a snapshot of the universe approximately 300,000 years after the Big Bang. Back then, the universe was a dense sea of plasma, with waves, BOs, rippling through it. As temperatures cooled, atomic nuclei absorbed most electrons, forming complete atoms and allowing light to pass unhindered for the first time. This light is what we detect as the CMB. The CMB is speckled with temperature variations, the final imprint of the acoustic waves that once traversed the dense plasma. These peaks and troughs are the blueprints of the cosmic web of matter, where galaxies and galaxy clusters began to form. The Big Ring, according to Alexia Lopez's hypothesis, could be related to these BAOs, which should appear as spherical shells in the arrangement of galaxies. However, the Big Ring's size and non-spherical nature defy this explanation. However, these theories do not fully explain the existence of the Big Ring and the Giant Arc. So, what could possibly account for these ultra-large structures? The question hangs in the air, like a star waiting to be discovered. One suggestion comes from Alexia Lopez, the same astrophysicist who discovered the Big Ring and the Giant Arc. She moots the idea that these structures might be related to baryonic acoustic oscillations, or BAOs. These are waves that arose from oscillations in the early universe, and today they should appear as spherical shells in the arrangement of galaxies. However, the Big Ring doesn't quite fit this explanation. It's like trying to squeeze a square peg into a round hole. The Big Ring is far too large, and it's not spherical. It's more of a slinky shape, coiled and stretching across the cosmos. It's a bit like trying to explain why a zebra has stripes, but you've only ever seen a horse. There's a sense of cosmic irony here. Just when we thought we had a grasp on the universe, it throws us a curveball, or in this case, a ring and an arc. The enigma of the Big Ring and the Giant Arc remains, leaving us with more questions about the complexities of our universe.